This video will give you a little bit of information about two-way within subject designs and effect size. Within subjects designs are designs where each participant is tested under multiple conditions. So each level of your independent variable, where your independent variable is what establishes the groups that are being compared when you're doing mean comparisons in ANOVA. But within subjects designs is that every single participant is in every single level of that independent variable. And this is what the equation looks like for this type of model. Very similar to the between subjects designs, but slightly different based on the variances that are being used. These within subjects designs are also called correlated error models, but the one that you would most likely hear is repeated measures designs, or this is can also sometimes be called longitudinal ANOVA. So this goes by several different names. But regardless of the name, the biggest point is that every participant is in every level of your independent variables. So each participant is in each group. So now your ANOVA is more like a paired sample t-test than an independent sample t-test. So for the between subjects designs, you have independent groups where the participants in each group are only in one group. Whereas with now the within subjects design, it's like a paired sample t-test where we use paired sample t-test for like a pre-test, post-test comparison. And this is where every participant is in both groups. It's both in the pretest and in the post-test. But now we have 3 or more of these groups to be able to do this within subjects designs ANOVA. And so the subjects are providing multiple values for the dependent variable. And so for each level of the independent variable, each participant will have a value for the dependent variable. So the means of the dependent variable are still what's being compared across the groups, just as in any other ANOVA design. But now you have each participant is at every level of the independent variable. And so this repetition can be over time, and most often we see it over time. So it's 3 or more time points where each participant has a value of the dependent variable at each of those time points, but it could also be over treatments where it's like a leveling or a stacking of treatments, or it could be something where it's the increase of sessions, so the number of sessions, but you are measuring the dependent variable at each session. So then session 1 dependent variable value could be compared to session 3 dependent value and look and see if there's mean differences across all these different treatment levels. So just like with one-way ANOVA designs, it's very important to report your effect size, and your effect size would be based on the industry in which you are conducting the research and reporting these results to, and also how you would be applying or the practical sense of these results. So remembering that your effect size is your practical significance. How well is this going to be able to be applied, and how useful are these results really in the real world? So then all of these effect size options are very much related, and so you are actually looking at these effect sizes in partial ways, because you want to look at the effect sizes of your main effects and your interactions. Because if you're getting statistical significance, you're getting an F ratio for each one of your factors that's included in your factorial design, and you're getting a F ratio and statistical significance for any interactions that are included in your factorial design. You also should be getting effect sizes for each of those as well. So you can look at effect sizes for each of your factors separately. And you can be able to apply different effect size choices based on what's happening with each of your individual factors. And so you can make sure that you have the appropriate effect size for each of the factors individually, and then your interaction as well. And so you want to really make sure that whatever effect size you're choosing to be able to use for each one of your factors is going to keep the factors independent from each other. And so in this example here, because we have this sum of squares error, that sum of squares error is going to be the same for both factors and the interaction. And so this can be problematic, and now those effect sizes are dependent on the other factor. And so instead, we are choosing to do this omega squared effect size to ensure that we keep the independence, where only the information related directly to that factor is used in estimating the effect size of that factor. And same with your interaction. And so you'll want to still use your criteria of industry and practicality to select your effect size that you will be using, but now you also have to think about making sure that those factors remain independent. So for two-way within subjects, you have to take into consideration this effect size. So first, remembering that for a two-way within subjects designs, you get your main effects for each one of your factors, but then also for your subjects, you get your interactions between your factors and the interactions between each of your factors and your subject, and then you get this three-way interaction between your two factors and your subjects. And so for each one of these effects, you should get an effect size, but it's calculated a little bit different because every participant is included in every group or every level of the independent variable. And so this is the formula. So this partial omega squared is typically what is used to calculate effect size for these within subject designs. And it's really helpful to use this one because it's calculating the effect of each one of the factors, so each one of the effects independent of others. So it's similar to a partial correlation in regression where you are partialing out the other factors and the effects that the other factors are contributing in order to get full information about the specific factor that you're looking at. And so it is the same formula as for a factorial design, but because you here are essentially doing a similar set of effects as a three-way between subjects design, this partial omega squared is the effect size that would need to be used.